In our last example, we're going to look at something that's commonly called a mixing problem. And in these problems, chemical in a liquid solution runs into a container holding the liquid, and the liquid in the container might also have a specified amount of the chemical dissolved in it. And we assume that the mixture is kept uniform by stirring and flows out of the container at a known rate. And this process can be described by a differential equation. The rate of change of the amount of the chemical in the container is the rate at which it arrives minus the rate at which it departs. And of course, this can be translated into derivatives and gives us a differential equation. Let's look at an example. Suppose a vat at Guinness's brewery has 500 gallons of beer in it, and that beer has 3% alcohol, so it's got 15 gallons of alcohol. And beer with 5% alcohol per unit of volume is pumped into the vat at a rate of 5 gallons per minute. And the mixture is pumped out at the same rate. What's the percentage of alcohol in the vat after 1 hour? Well, we need to create some variables here, so we're going to let y of t be the amount of alcohol in the container at time t, and we let v of t denote the amount of beer in the tank at time t. So we see that the amount of alcohol in the container at time 0 is 15 gallons, so y of 0 is 15. So we have an initial condition, and v of t, the volume of beer in the tank at any given time, doesn't change because liquid is coming in at 5 gallons per minute and leaving at the same rate. So v of t is a constant. It's just 500 for any value of t. And of course, our question is, what is the percentage of alcohol after 1 hour? In other words, what is y of t divided by v multiplied by 100 after 1 hour. The rate of change of the amount of alcohol in the container is dy dt, and that's the rate at which the alcohol is arriving minus the rate at which it departs. So it's arriving at a rate of 5% of 5 gallons per minute, and it's leaving at a rate of the proportion of alcohol in the container y of t over v times 5 gallons per minute. So let's tidy this up a little bit. We have dy dt equals 0.05 times 5, that's 5% of 5 gallons, minus y over 500 times 5, and that's 0.25 minus y over 100. And of course, we don't know what y is yet. It varies as t varies, and we're very interested in y of 60. Adding those two fractions, we get 25 minus y over 100 equals dy dt. And now we'd like to solve that differential equation, and we see that it is a separable differential equation, and it has an initial value. So we want to find y of 60. We separate the variables. We get dy over 25 minus y is 1 over 100 dt. And then we integrate both sides, and we get minus the natural log of the absolute value of 25 minus y equals t over 100 plus a constant. And now, to solve for y, we apply the exponential function to both sides after we multiply by a minus, and we get the absolute value of 25 minus y is e to the c times e to the minus t over 100, or 25 minus y equals plus or minus e to the c times e to the minus t over 100, and we can rewrite that plus or minus e to the c can take on any value, so we can just write it as a general constant k. So our solution is y equals 25 minus k times e to the minus t over 100, and we're interested in the value of y when t is 60. So we have y of 60 is 25 minus 10 times e to the minus 0.6, and that's 19.512 gallons roughly. So the percentage of alcohol in the tank after 60 minutes is y of 60 over the 500 gallons in the tank times 100, and that's 3.9%. And this makes sense because the beer in the tank to start with has 3% alcohol, and the beer coming in has 5% alcohol, so we would expect an answer somewhere between 3 and 5%.